Moving on, now we have formulas for capacitors. How would we connect capacitors in series and parallel with a circuit? What are capacitors in series? Consider this: capacitor 1, capacitor 2 and capacitor 3. These are in series now. There is a simple logic behind being in series is one plate of one capacitor is connected to another plate and there is no further attachment in between any two capacitor. If there is any other wire between any two capacitor, I would not call it in series. Remember this formula. This is a very simple thing to know. In this case, it is quite easy to figure out that these capacitors are in series. But once you get complex diagrams, I'll explain you the same thing again, how to figure out which capacitors are in series and which are in parallel and where to start your circuit from. For now, capacitors in series. These three capacitors are connected in series and I have given them a voltage V. What do you think will happen to charge on each capacitor and the voltage with each capacitor? See, this voltage will be totally consumed by these capacitors. For example, if this is 6 volt, the voltage will be divided in like 2 volt, 2 volt, 2 volt or 1 volt, 2 volts, 3 volts, but total 6 volts will be consumed. That means if C1 has a voltage V1 right now, it has taken a voltage of V2 and this is having a potential difference of V3. Now, if I use the term voltage and if I use the term potential difference, will it make any difference in your head? Will you get confused? I would suggest don't. Potential difference, voltage, they all mean the same. There is only one difference between EMF and potential difference. So when we use the word EMF, we specifically make the difference and we use internal resistance as well along with the term EMF. That we will be doing in detail in next chapter, next unit, which is current electricity. For now, please don't create any confusion between potential difference or voltage. So this is the potential difference. This is voltage difference across plates of C3, right? What I was explaining you before, that total voltage is V1, V2, V3. This is how it will be. 6 volts divided into parts, which when added up gives you 6 volt back. But if there is a current I flowing through it, the same current has to pass through each capacitor, right? Actually, capacitor do not allow DC current to pass through it. This is a fact. You will be studying this fact in electromagnetic induction alternating currents. Capacitor do not allow DC currents. But in this chapter, in CBSE, some books plus help books, you have to face diagrams. You have to solve those diagrams where the capacitors, a group of capacitors are connected across a voltage and you have to solve for the final charge, total capacitance. So for now, you have to consider this, that total current which is passing from this circuit, this current did not get any other route to flow. That means the same current will pass through each capacitor, due to which charge on each will be same. There are two methods of understanding this fact. First thing, the current. There was no other diversion for the current to flow, due to which current is rate of flow of charge, charge was equal. Number two, if this plate got charge Q, an equal and opposite charge got induced in this plate, and equal and opposite in this plate, equal and opposite in this plate, equal and opposite in this, and then this. So charge is always equal. So remember, in series, charge is equal. What was our formula? Q is equal to CV. From here, V would be equal to Q upon C. If C is the overall capacitance, considering this to be one capacitor across which V volt is connected, so that C is this. But overall charge, if this battery has sent charge of 10 microcoulombs, if there are 10 capacitors or 3 capacitors, doesn't matter, the battery will be sending 10 microcoulombs only. So charge would be same. This charge For V1, I'll be using what? What is V1? It is Q1 upon C1, and Q1 is by chance Q only. So Q upon C1 plus Q upon C2 plus Q upon C3, not Q2. Cancel out Q, take out it common. Your answer would be 1 upon C, 1 upon C1 plus 1 upon C2 plus 1 upon C3. How many of you have noticed any grammatical error in whatever I am saying? If you have, that means you were not focusing on what I was teaching. So, this is the formula for capacitance in series. Net capacitance is given by this formula. We'll apply this formula in a while. What would be the formula for parallel? Yeah, right. Parallel is simple. The net capacitance in parallel is C1 plus C2 plus C3. But how do you derive it? Just a second and I'll tell you. The application of formula is simple. In parallel, they are not batteries, they are capacitors. So, please ignore any drawing mistake. Now, the parallel thing, this V volt is connected parallelly across 3 capacitors. That means each will have same amount of volt. But the current which went from this battery has got 3 routes to follow. That means the current will be divided into 3 parts. Either equally or unequally, depends entirely on the value of C. You know the current has a property that current follows the least resistive path. We will discuss that also, but for now we know that current has divided into 3 parts. I is I1 plus I2 plus I3. That's right. What is I? Rate of flow of charge, right? That means whatever total charge which has been sent from this battery has been distributed into equal or unequal parts Q1, Q2 and Q3. So here are the values which you should actually be writing. That total charge, if it has a total charge Q, this has got charge Q1, this capacitor has got charge Q2 and this capacitor has got a charge Q3. So this equation, instead of this equation, what you should be writing is total charge is Q1 plus Q2 plus Q3. What is the formula for Q? C into V. If C is the overall capacitance, C into overall voltage which is V, and for Q1 it will be C1 into V1, but V1 is V only because in parallel voltage is same. C2 into V plus C3 into V. Take out V common and cancel it out. You will be left with C1 plus C2 plus C3. So this is the formula for capacitor in parallel. Now formulas are simple. What about rules to figure out which capacitors are in series and which capacitors are in parallel when you are solving a complex circuit? Let me give you an example of 2 simple circuits. See if you could figure out where to start solving them. C, 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 each capacitor has a value of C farads. I have to give the net capacitance between point A and B. While doing or solving circuits like this, first of all, if you are more comfortable with the values, I'll give you the values, okay? Take the values, let it be 6 microfarads, 6 microfarads, 3 microfarads, 6 microfarads, then 3 microfarads, and then this is also 6 microfarads. There is also 6 microfarads. This is 12 microfarads. This is 3 microfarad and 3 microfarad. Now, if you are more comfortable with these values, you can solve the question accordingly. Where will you start looking for or to start solving from the diagram? Should I start from here or these 3 in series? Should I take these 3 in series or these 2 in parallel? 2 simple rules. Number 1, capacitors are not in series if there is any single wire which intersects their path. Any single wire. Even if these are 2 capacitors which are actually in series now, if I take out any wire from their midway or from the path which is connecting them, they are not in series anymore. Unless and until nothing is connected on the wire. If something is connected here on the wire, they are not in series. So, which two capacitors are connected in series now? In this whole diagram, this one and this one. Because the wire connecting them, this wire, there is no further deviation in the wire. There is no further connection made on this wire. Take any other 2. Like this and this capacitor. There is this point, there is a wire connected here, so these 2 are not in series. These 2 are not in series because of this wire. So you can take any 2 wire. These 2 are in series, so in series you can simply add these up and there will be net capacitance. What will be the net capacitance of 6 and 6? It will be 1 upon 6 plus 1 upon 6, that is 2 upon 6, 1 upon 3, inverse 3. So instead of these 2, you can make just one of 3 microfarads. Now, some students actually get confused about this was the capacitor. You can make the wires whatever shape you wish to. This capacitor and this capacitor can be redrawn like anything. The most important part is that they have to be in series or parallel as they were before. That is it. Wires don't matter, and sometimes if there is a wire which is not having any component, electrical component in between, you can simply short the wire. Carrying on to our problem. Now, these 2 capacitors are in parallel. Which 2? The simple formula for finding out 2 capacitors in parallel is that both should have a common starting point and both should have a common ending point. What I mean by common starting point, these 2 capacitors have this point as common starting point and this point as a common ending point. Take any other 2 capacitors. Let us take this one and this one. These 2 have common starting point. Starting point doesn't mean to have that the capacitor should start from there. I am interested in taking those 2 wires. Take any of these wires. These 2 have one point common. What about the second point? This one is ending here, this one is ending here. So these 2 points are not common, so they are not in parallel. Take any 2, this and this, they are entirely different, so we cannot even talk about them. But these 2 have common starting and ending points, so they will be in parallel. In parallel, the formula would be C equal to C1 plus C2. So ultimately, your answer for this would be what? 3 plus 3, that is 6. Then this capacitor and this capacitor, they are in series now. So for this, the answer would be 6 and 6 would be 3. So instead of this 6, you can make 3 microfarads, and this 3 and this 3 are now in parallel. So this gives you 6 microfarad. So up to here, this is your circuit, 6 microfarad. There are 3 series capacitors of 6 microfarad. So their net resultant would be 1 upon 6 plus 1 upon 6 plus 1 upon 6, 3 upon 6, 1.2, inverse 2. So here we have 2 microfarads. Then 2 and 12 in parallel, and then the circuit is very easy. 2 and 12 in parallel is 14, and then 3, 14 and 3 are in series. You can sort them out. This was how capacitors are connected in series and in parallel, and how to point out which capacitors are in series and in parallel when you are doing a circuit.